Hello everyone. Today we are exploring one of the most powerful and classical vulnerabilities in computer security, the buffer overflow. Think of your computer memory as a series of slots on a shelf. When programmer creates a buffer, they essentially reserving a specific number of slots, let's say 64. For data like username, a buffer overflow happens when we send more data than those 64 slots can hold. The extra data has nowhere to go but down the shelf, spilling over and overwriting SN memory. The magic happens when we overwrite something called the return address. This is the instruction that tells the CPU where to go next after a function finishes by precisely calculating our spill. We can override that address with our own hijacking and the program and forcing it to run a secret function that was never supposed to be accessed. So let us understand the architecture. So by running the this function this program simulator.py, we will get the okay. So as you can see the architecture, starting buffer overflow simulations, it's just an example. So here you can see the stack states before attack. So as you know, our size is 64 bits. Let's look at the stack architecture. When a function is called, the computer pushes three critical things onto the stack: the buffer, the saved BRP, and the return address. In classical attacks, we fill buffer with junk overwritten in the RBP and then carefully place our own address into the return address slot. When the function tries to leave, it uses our own exit door instead of its own. So now let's see the vulnerability code. As you can see here, we are using the function called here getAs function. So getAs function we are using, as you can see, getAs of buffer. In our demonstration today, we are using the C language. C is powerful language because it gives you direct access to the memory, but it does not hold your hand. We are using getAs function. This function is so dangerous, it has been officially removed from C standard library. Why? Because it has zero bounds checking. It will keep recording your input until it hits a new line. So let's run this code. So we have created an execute function and then we run this actual executed function. So we have been generated a address secret secret function, address of secret function. It is never supposed to be accessed by anyone, but so let's we say hello. So this function finished normally because we are accessing only 5 characters, which is 5 bits out of 64 bits. Now let's let's exploit this. So to exploit this, we need to run the exploit.py code. So the address function is being accessed by this target address and this padding, which is very important. So by running this, we have built generated a successful payload. The payload length may be anything. So now let's perform the exploit. So let's see the length of it. It is 224 characters, but our string only accepts 64 characters only. So now let's run the now let's release this payload.build as we already created. Now cmd exit.payload. So we are using technique address spraying because modern memory can be bit unpredictable. We repeat our target addresses, the location of our secret function dozens of times in our payload. Watch. We generate the payload with Python, ensuring we use raw binary encoding. We pipe it into our vulnerability functions and it is the program did not crash. It executed our secret function. We successfully executed the control flow. As you can see, first of all, we successfully